In this video, we're going to work with parallel and perpendicular lines. Here I have two examples. I've got two sets of lines. The first set of lines are parallel, which we can think of as lines that never cross as they go out forever, but mathematically we want to compare them with their slopes. So I'm going to number these as line number 1 and line number 2, and we're going to find their slopes. Here's a nice point and here's a nice point. To get from one point to the other, I need to move down 1 in the y direction and over 1, 2, 3 in the x direction, which means that that first slope, we'll call it m1, is equal to negative 1 over positive 3. Now let's look at the slope of the second line. Of our second line, I've got a nice point here and a second nice point here. To move from one point to the other, I'm going to start at this one. I need to again go down 1 in the y direction, that's negative 1, and positive 1, 2, 3 in the x direction. So that second slope, m sub 2, is also equal to negative 1 over positive 3, so negative 1 over 3. So what we notice with these parallel lines is that our slopes are equal. So for parallel lines, we have equal slopes. My second set of lines are perpendicular. Perpendicular lines meet each other. Let's see, perpendicular lines meet each other at a right angle or a square corner right here. But again, we want to compare these with slopes. So as I'm looking at these lines, I'm going to have line number 1 and a line number 2, and I'm going to look for a couple of nice points to figure out what their slope is. So for the line number 1 here, I'm going to use the point at the origin and this point. So for this one, I need to go down 2. So for slope 1, that would be negative 2 in the y direction, and then I follow that 1, 2, 3 in the x direction. So my first slope is negative 2 over 3. For my second line, I'm going to pick this point and this point. I need to go in the y direction, up 1, 2, 3, so up 3 in the y direction, and then over 2 in the x direction, which means that that second slope, and m sub 2, is positive 3 over positive 2. If you take a look at these two slopes, you'll notice that, in a way, you can think of saying everything is different. I had a 3 over 2 for that second slope. In my other slope, I had a negative 2 over 3. So they have opposite signs. One's negative and one is positive. And they also have reciprocal fractions, 3 over 2 and 2 over 3. So perpendicular lines have opposite reciprocal slopes. Basically, we change everything. Opposite reciprocal slopes. Let's look at a few examples. I want to take an example just using the slope. So I'm going to get rid of my graphs for now. And as we look at an example that involves just the slope, we're going to focus on the perpendicular lines because they're a little more challenging. This is the symbol for perpendicular. So we're going to look at two perpendicular lines. If I was given a first slope of 1/2, then that means that my second slope, which would be a perpendicular line, I need to take the reciprocal of that fraction and make it negative. I change everything. So it would be a negative 2 over 1, or just a negative 2. So 1/2 for one line, negative 2 for the other. Here's another example of perpendicular slopes. If my first slope was negative 3, then my second line's slope, if it was perpendicular, needs to be the opposite, so it will be positive. Opposite reciprocal. Think of that 3 as 3 over 1. Now I've got a fraction that I can reciprocate or flip. So it needs to be positive 1 over 3. So my second slope then, for the negative 3, second slope is a positive 1/3. Next we want to look at some equations. So for these equations, we want to determine if my lines are parallel, so that's my symbol for parallel, perpendicular, or neither. Here's our first example. So for the first example, we're given y equals 2x plus 1, and the second equation, 2x minus y equals 4. Well, the first equation is in the form that I want. I really want y equals mx plus b, because what I need to compare here to answer my question is the slope. So for my first one, I already know what my slope is, mx plus b. My slope is right here, and it's 2. So m sub 1 equals 2. Now let's take a look at the second slope, number 2. I don't quite have it in slope-intercept form. I need to solve this one for y. So the 2x needs to move to the other side. Subtract the 2x from both sides. That's 0. I bring down the negative y. I'm going to write my negative 2x first, and that's a positive 4. Negative 2x plus 4. I'm almost to y equals mx plus b, but I don't want the negative here. Think of that as negative 1. I'm going to divide all 3 terms by a negative 1, which gives me, finally, slope-intercept form. Y equals negative 2 over negative 1 is positive 2x. 4 over negative 1 is negative 4. Here's my second equation. So this is number 2. I know that my slope is right next to x in this form. So my second slope here, m sub 2, is also 2. So I have the same slopes, which means that these two lines are parallel. So my 2 lines are parallel, and that's my answer. Let's look at one more example with these. B. So for our second set of lines, let's have the first line be y minus 3 equals 2x, and our second one represented by negative x minus 2y equals 6. Neither of these are in the form that I want. I really want y equals mx plus b. So I'm going to take these 2 equations and get in that form. So you need another piece of paper, and I'm going to give myself some room. I'm going to work with equation number 1 first, and I'll put it on this side. So number 1. Y minus 3 equals 2x. I'm actually really close. I just need the 3 on the other side. So I'm going to add the 3 to both sides, which gives me y equals x term first, 2x plus 3. My slope is right next to the x. So in this one, slope is equal to 2. There's that 2 again. So I'm going to call it m sub 1 equals 2. Okay, let's see what we've got for equation number 2. Equation number 2, negative x minus 2y equals 6. I really want that form though. I want the y's on one side, so I start by moving the x. I will add it to both sides of that equation. That's 0. Negative 2y comes down. X term first, so x plus 6. But now I've got negative 2 times y. I need to divide all 3 of my terms by negative 2 so I can isolate that y, which leaves me with those cancel. Y equals, put a 1 there so you can pull that slope out, which is that 1 over negative 2. I'm going to write it as negative 1 half x. 6 over negative 2 is negative 3. 1 half x minus 3. Oh, there's slope-intercept form. So I can grab my red pen. Slope is right next to the x. There's my second slope. M sub 2 equals negative 1 half. Do you know what we have here? I'm comparing my slopes. I have 2, so I've got a positive 2 for one slope. A negative, that's the reciprocal. Think of that as 2 over 1. A negative 1 over 2 in my second slope. And I can say that these 2 lines are perpendicular.